Dear all, welcome to our channel. Uh, as we seen the last video, solution of first order PDEs, there are five types. So how to find the solution for that? Actually, solution method I am giving it here. So this video may be much helpful for you to understand how to find the solution for each type. Actually, first you need to understand the type. Whenever the question is given, you need to understand the type. So type 1, we will start with type 1. Type 1, the example may be like p square plus q square equal to 1, along with some constants or any arbitrary constants, p and q only will be there. So you need to assume the solution as ax plus py plus c. This is a general way to do this kind of type. So for this type, you have first complete solution has to be found, then singular solution and general solution. In every type, you need to find complete solution, singular solution and general solution. So for this type, you can assume z equal to ax plus py plus c. Then you can eliminate constants one by one so that you can get the actually ax plus by. It is not px. Sorry for the mistake. Actually ax plus by. So there are three constants. You can eliminate one by one. So you will get the things. As per our discussion in the class, we can do that. Similar to first type, we can have a second type, z equal to px plus qy equal to f of pq. This is called Claret's form. For this type also, we can find a complete solution, general solution, singular solution and general solution. But for this type, you just assume p equal to a and q equal to b. That will directly gives us complete solution or complete integral. Then you can find a singular solution by finding the derivatives with respect to the a and b, the constants, and then general solution will be found. Similar way, for the third type, that may be the example. One of the example I have given each type an example is given here. So in that way, z square equal to p square plus q square minus 1 is one of the example. To find the complete solution, actually in this type 3, we may convert the given PDE to ODE by assuming u equal to x plus ay. So z will become function of u. So in that way, we will find the complete solution. Then there is no singular solution for this type. Actually, the first type and this type or even other types, only your Claret's form have singular solution, because if you differentiate with respect to A and or C, here you can differentiate with C, you will have 1. You are not able to make it equal to 0. So that reason has to be mentioned. You need to compute and the reason has to be mentioned. So in that way, you can find the singular solutions. Similar to that, in the fourth example, so p square minus x, q square minus y. You can separate like this: y plus q square, then x minus p square. That will become variation separated. Then you can find the solution by integrating those. So this is what fourth type. And Lagrange linear equation have a separate methodology, because it may not comes under these types. It is a linear equation. First, the one of such form is given here. So xyp yzq plus zx. Actually p, I didn't give anything here. Actually small p, it's here. I just given capital P. Actually xy is capital P and yz is q. Based on that, you can write a subsidiary or auxiliary equation like dx by p, dy by q, dz by r. So here already three terms are there. With these three terms, if you are directly integrate, you can solve it. Otherwise, if you are not able to integrate directly, so if required, that's what I mentioned. If required, one or more terms is to be formed using the multiplier method. So based on multipliers and this term, you may have two or three more terms. So if you compare any two terms by integrating, you will get the each of the constants. So after finding those constants, you can write it as a general solution. So I hope you all get this idea. So thank you all.